Okay, in this question we have switch 1 had been closed for a long time while switch 2 is open. Switch 2 is open, so during the charge this part of the circuit was irrelevant, so we fully charge the capacitor to a voltage Vc is equal to V. It's not really important here, but we wrote it down anyway. The charge across the capacitor then is going to be the overall charge that we are going to collect in the capacitor is going to be V over C. Now, we open S1, close S2. We have the discharge now. Q0 then is going to be equal to V over C. Now, the equation for discharge, Q of T, is given by Q0 exponential minus T over RC. We are given R and C here, so we need to calculate our RC time constant. RC is equal R, we need to get the R that we use for the discharge, and the R that we use for the discharge is simply R, not twice R. So it's going to be 4 ohms times 15 times 10 to the minus 3 farads, 15 millifarads. So that comes out to be 0.06 seconds. In this question, they are asking us for the charge when at 0.06 seconds, at that same time as the time constant. So that's going to be Q0 exponential. We have the same terms in the numerator and denominator, so exponential minus 1. Okay. Now anyway, if you recall, for the graph of the discharge, if this is Q, that's time, it's going to look like this, with this as being Q sub 0. After tau, after a time constant, tau, remember, is our RC, we are going to lose about 63% of the charge. Meaning we are going to be left with about 37% of the charge. So from here to here is going to be 37% of the charge. So that's what we got. You know, mathematically, if you calculate it, exponential of minus 1, it will come out to 0.368. Okay, now we have essentially the same circuit, but a different resistor is 2 ohms, and then we have 2R here and R here, so they were flipped. And S2 is closed fully from the beginning. So after we close the switch for a long time, we open it. What's going to happen? Okay, when we close the switch, we are going to charge the capacitor. But we are going to charge it in this case to a Vc that's not equal to E. It's going to be equal to how much? We calculated it before. Okay, we do it quickly. We have, when it is fully charged, the only current is going to be through the resistors, and then the outer loop is going to give me 3R times I equals to E. And I is equal to E over 3R. That gives us a voltage across the capacitor that's equal to twice R times I, which is in this case 2 E over 3, 2/3 of E. Volts. Now, the question is then, what is the charge on the capacitor 0.06 seconds after the switch is opened? Now, the discharge, the time constant is going to be the R for the discharge, which is twice R times C, and in this case, twice times 2 ohm times 15 millifarad. So that comes out to be 0.06 seconds. Okay. So they are asking us for the charge at 0.06 seconds, which is Q0 exponential minus t over tau. In this case, knowing Vc, I can find Q0 is Vc over the resistance that we have for this charge. The resistance that we have for this charge is twice R. I mean, what am I talking about? Q is Vc over the capacitance. I'm not talking about current here, I'm talking about charge. So Vc over C. So we have that. And then the exponential then is going to be Q0 exponential. My t is the same as tau, exponential minus 1. So my Q at 0.06 seconds is going to be like the same number that we dealt with here, 0.368. 0.368 times Vc 16 volts over C 15 millifarad. Okay, now if we calculate that, okay, now let's do that here. I'm going to go through the step of calculating exponential minus 1. So I have 1 minus inverse log. Let's see, that's the 0.3678 that we rounded out to 0.368 here. Okay, so we are going to multiply that by 16 volts divided by 15 10 to the minus 3. So it's 1067 coulombs. That's a huge charge, and that's because the capacitance, 15 millifarad, is a large capacitance. That's not a normal capacitance.